back. This is Engineer Hussein Wasapi. So in this video, we'll be looking at how to derive the sum of a geometric progression. So before we begin, do not forget to like and subscribe. Alright, so when it comes to deriving a geometric series, we need to follow these steps. So for a geometric series, we end up finding the sum as follows, where we have a plus the first term again being multiplied by the common ratio, which will give you AR. Then again repeat the procedure where you say the common ratio multiplied by the second term, which will be AR times R, which will be AR squared. Then again plus the same third term, because this is term 1, term 2, and this is term 3. So term 4 will be found by term 3 being multiplied by R, which will be AR to the power 3, and this keeps on going just like that. So the sum of the first n terms is given by S sub n being equal to a, open parenthesis 1 minus r to the n over 1 minus r. So for this condition, let us try to derive the given statement for the sum of a GP. So to prove this, or to show that the sum is equivalent to what we just shown, we can say that proof, or rather to show that S sub n is equal to a, open brackets 1 minus r to the n over 1 minus r. The first thing we're supposed to do is to let S sub n be equal to what the sum would be. I would say a plus ar plus you multiply by r, which would be ar squared, then plus ar to the power 3. Let's write this cleanly. Plus ar to the power 3 plus ellipsis, keeps on going like that, plus as you keep on going approaching the end, you reach a point where you have ar to the power n minus 2 plus ar to the power n minus 1. So let me call this my first equation, so equation 1. So now once you write your first equation, all you have to do is to multiply the entire equation by r. So I'm going to say r is multiplying everything, which is S sub n being equal to a plus ar to the ar squared plus ar cubed plus plus ar to the n minus 2 plus ar to the n minus 1. Now what happens when r multiplies everything? We end up having the following. Well, r sub n being equal to ar plus ar squared plus ar cubed plus ar to the power 4 plus plus ar. Now since it's n minus 2, when we add another r to it, the minus 2 plus 1 will be ar to the n minus 1 plus ar to the n, like that. And let's call this equation number 2. So all we have to do now is to subtract equation 1 from equation 2. And by doing so, if we end up subtracting, we'll be having S sub n. I just hope you're writing this down as well, because it's a bit lengthy. So let me write it on the next part of the screen. So this will be, if we subtract what we have, let me just rewrite what we have as our equations. We have S sub n being equal to a plus ar squared plus ar cubed plus dot 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 plus ar to the n minus 2 plus ar to the n minus 1. This is equation 1. Then equation 2 is r s sub n being equal to ar plus ar squared plus ar cubed plus ar to the 4th plus dot 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 plus ar to the n minus 1 plus ar to the n. This is equation number 2. So now, when we subtract this, we end up having s sub n minus r s sub n being equal to, now as we are subtracting, we end up having this format. So we have the following. We have a plus ar squared plus ar to the power 3 plus dot dot dot. So this is equation number 1 that I'm writing, plus ar to the n minus 2 plus ar to the n minus 1. And the whole of this is being subtracted by ar plus ar squared plus ar cubed plus ar to the 4th plus dot 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 plus ar to the n minus 1 plus ar to the n. And now, if you subtract this, what you're going to end up having is that if you factorize, let me just say, not factorize, rather, let me just subtract. If we subtract the first left-hand side of the equation, which is this portion, if we just subtract, you find that they are like terms, so nothing will really happen. So we have s sub n minus rs sub n. But as we are subtracting the other side, you find that things will start to cancel out. This part will cancel out with that part, that will cancel out with that, this will cancel out with that, and so on and so forth. And you find that as you keep on going, even ar to the power 4 will cancel out, and ar to the minus 1 will cancel out, and even this will cancel out. And as a result, we end up just remaining with a minus ar to the n. Therefore, if we factorize this, we'll be having s sub n being, open parenthesis, 1 minus r being equal to, let's factorize also on that side, we have a 1 minus r to the n. Then this is over 1 minus r, then over again 1 minus r. Therefore, we have s sub n being equal to a, open parenthesis, 1 minus r to the n over 1 minus r. And this shows the sum of the geometric progression. If you have any queries, you can reach out to me on WhatsApp on the line plus 260 77 149 5252. Remember, slow progress is better than no progress, and let's strategize before becoming a statistic. Let's try and push for that A+.